Now you need to go back to this. Okay, right. Exercise 15.1. I hope everyone has this in front of you. And also make sure that you are listening. Okay, right. Briefly explain why the benzene molecule is polar. So polar, planar. Sorry, planar means it has something to do with the shape. So the shape usually involves, the nature of the carbon, how many bonds there are around your carbon center, and etc. So the answer for this is. Of course, you can talk about the carbons being hybridized. And in benzene, what is the hybridization for the carbons in benzene? Hello, sp2. Okay. Why can't you just say it instead of like chatting? Next time I will just hybridize, can't spell. Next time in class I just ask you to type it out. Carbons is carbons are sp2 hybridized, okay? Or you can say that the carbons are bonded at 120 degrees. Now 120 degrees, what's the shape? What's HCC? Oh yeah, bond angle, that's right. Bond angle 120 degrees. So what is the shape when you have 120 degrees? There's only one mark for this question, so you can choose either one. Yes, Mukri? What's the shape? Trigonal planar, thank you. Trigonal planar. So of course, because each carbon is a trigonal planar, and you know that planar means plane, flat. So that's why overall the benzene is a planar molecule. Briefly explain why all the carbon-carbon bonds in benzene are the same length. Now, Kekule said that benzene is actually made up of 3 single bonds, 3 double bonds, okay? But when they analyze this structure of benzene, it turns out that the bond length of the benzene ring it doesn't show the 3 single bond and 3 double bond. Okay, it is an intermediate that shows you that the bonds inside the benzene ring is not strictly positive, negative, positive, negative. Okay, they're actually an intermediate. So to answer this is because the double bonds are delocalized. Okay, double bonds is not fixed. The double bonds move. Let me know if you don't see anything being written on the screen, okay? Because just now with block 4, I was talking for like 10 minutes. This is being recorded. I was talking for 10, 15 minutes, I think, only to realize that there was nothing on the screen. And then they didn't say anything. So, yeah. You know how it feels? Well, you don't know how it feels until you become a teacher. Okay, so double bonds are delocalized, so that means the pi electrons are delocalized as well. So you can just choose any one of these points because again, this question carry 1 mark only. Okay, next one. Now I am going to give you some hints only because I want you to use your brain. Right. Both ethene and benzene react with bromine, but the mechanisms and the types of products of 2 reactions are different. So this first equation is for alkenes. So please revisit your AS notes. Otherwise, you will never use your notes to find the answers if I give you everything, okay? So alkenes react with bromine. There's a specific mechanism. Some of you may remember it already without even looking at the notes. That's great. And then the bottom one is the benzene. So this one you can just refer to your notes. And I hope by now you should already remember the mechanism for benzenes because I've been mentioning it a lot of times already. Okay, so you just have to write down the mechanism. Like, is it nucleophilic substitution, nucleophilic addition, electrophilic substitution, electrophilic addition? That's what I mean by type of reaction. Please write down in full, okay? Do not just write down addition reaction. That will not sometimes that will not give you the full marks. Okay, so please make sure you write down the full name of the reaction. Can we move on? Okay, here you have to draw the mechanism. Again, I will not show you the mechanism because I want you to refer to your notes. But basically, the intermediate for these two reactions, they have different mechanisms, slightly similar, but different. Carbocation intermediate. A carbocation intermediate means there is a positive charge on your carbon. So please look out for that intermediate when you revise your notes later on. Okay. Why do ethene and benzene differ in their reaction with bromine? Now, both of them have double bonds. Okay, benzene have double bonds. Ethene have double bonds, but the only difference is the double bond in benzene is that it is delocalized. Okay, and we know that the delocalization is stable. That means you see the delocalization being broken, but then after that it must be restored. Okay, so delocalization is actually stable, right? Delocalized ring of electrons is stable. Okay, for 1 mark you can say that, or you can say the pi electrons in ethene are localized. So there's the difference. Okay, localized means fixed. Delocalized means not fixed. It moves. Okay. I really like this iPad. I think I'm going to use this in lesson when school reopens. Okay, question 3. Are you all with me? Do I still have you all on the line? Or do you just put me on and then you go to the kitchen and make some breakfast or something? No. Okay, good to know. Right, so your starting material is this CH3, okay? And then you have 2 roots, root 1, which is going to the left, and root 2, which is going to the right. So your reagent here is chlorine, okay? Both of them uses chlorine, but they have different reactions, okay? So if you look at this chlorine, who went missing? Someone went missing. Nick, I think. Must be his internet connection. Okay, so what happens to your chlorine is attached to the ring. So the reaction is considered in the benzene ring. So you have to look at the reaction of benzene. We've already covered this also recently, okay? For B, reaction number 2, the chlorine is attached onto the side group or side chain, which is alkyl in the alkyl side chain. Okay, so the mechanism has to be of your alkyl or alkane, same thing. Alkane and alkyl, same thing. Okay, so if you read the question, it says state the conditions. Okay, you only need to write down the conditions, the catalyst, whether you need heat, whether you need light, or you need other things. You do not have to write down the reagents, okay, because reagent is already given. Reagent is Cl2. So you really have to read the question, okay? It's only asking you for the conditions, which is catalyst, if there is, other condition like heating, light, or whatever. I won't say it, otherwise I'll be giving you the answer. Okay, so that's question 3. Okay, so far? Last one, question 4, even easier. So you are to write down the reagents and the conditions needed to convert benzene into chlorobenzene. So this is all your, this is your halogenation process where you start with a benzene and then you form a chlorobenzene. Okay, use your notes, please. It's that easy. The second one is bromobenzene, bromination. It falls under halogenation as well. This time you attach bromine. Just be careful when you use bromine as your reagent, your catalyst has to match, okay? Yes, it has to match. That means it has to follow the bromine. Okay? Last one is nitrobenzene, is when you attach nitro group onto your benzene ring and O2. Okay, again, everything is in your notes, right? The next one is showing you the mechanism of benzene. The nitration of benzene can be represented as follows. So you have benzene ring and then that A. That A plus is actually your electrophile. Okay, so in the exam, you know, maybe right now it's easy to see like, oh, obviously A plus is my electrophile, but in the exam it may not be as easy. Okay, so you have to draw the structure of intermediate B. Your intermediate B will involve a broken delocalized system with a positive charge somewhere, but make sure your structure of intermediate B, you draw out the full formula of the electrophile. Okay, do not use A plus. Draw out full formula of A plus. Okay, don't use A plus. Once you've identified A plus, then you draw it as the intermediate. Okay, done. Question 1 to question 4 for tonight. Tomorrow, of course, it will be because it will be a long weekend for you, and some of you will be hungry. Well, some of you are enjoying eating in the daylight. Right. So